Da-da-na-na-na, da-da-na-na-na. That's like a detective show from the 50s, so if you can get that one, I'll be way impressed. So there were 5 pieces that we needed to get this answer. We needed to know it's not blue. We needed to know the value for the null and the value that we were picking for the alternative. The sigma, the sample size, and the alpha. Those are the 5 pieces that helped us get to the final answer. So let's look at each of those, starting with the 2 mu's. The mu for the null hypothesis and the mu that we picked for the alternative. I called it mu naught and mu a. What happens if we move those and shift them? Look over here at the picture. Well, whether it shifts right or left, if they both shifted left, we'd end up with the same pictures. So it's more about how close are they from each other. In other words, how far apart they are from each other. Some places call this the delta. I'm not going to use that terminology in our class, but the idea is what's the difference between them? How much is it changing to go from null to alternative? Because we're talking about power, not confidence, power, we're assuming the alternative is the truth. So we want to be able to tell that the null hypothesis is a lie. The closer the null and the alternative are to each other, the harder it's going to be to tell that the null is a lie.
Not to mention the angry mob that'll come after us when there's no more power, but hey, at least we had some laughs, right?
If they're way far away, it's going to be like, oh, the null hypothesis thought the data was going to be here. It wasn't anywhere near there. The data was clear over here. So if that distance increases, then the power is going to go up. And that should make sense if you look at these pictures. If I spread the black and red curves further apart, this line is going to shift down along with the black curve and give us more area. If I squish them closer together, this line is going to move in on the red area as the black curve moves with it, and you would have less power, less ability to tell that the null is a lie because the truth was so close to the null. Let's take a look at the other variables and see how would we change them to get the most power. In other words, what's going to make it easiest for us to tell that the null hypothesis is a lie? Sample size. What do you want? A little bit of data or a lot of data? The more data you have, the easier it is to tell what's going on. Over here with the picture, if you have more data, then sigma over square root of n gets smaller. These start to skinny up. Your results become more accurate. As these distributions get skinnier, this line travels in closer to where the null is, which means the line is going to go out back to where the null is, and that will give us more power. You had more data. Obviously, it's easier to tell what was true, in this case, the alternative hypothesis. What about our standard deviation? It's going to work opposite of sample size because we take sigma divided by the square root of n. If you have a smaller sigma, that's what makes these shrink up. Smaller sigma means less error. If you have less variability, if your results are more consistent, then it's going to be easier to tell what the truth is. If sigma goes down, then the power goes up. What about alpha? As alpha goes up, that's your type 1 error rate, then the type 2 error rate, that's beta, will go down because they're opposites. Alpha goes up, beta goes down. Type 2 error rate is the opposite of power. So if type 2 error rate goes down, power goes up. Alpha goes up and the power goes up. That's confusing for some students because alpha going up means more error, and that seems bad. How come the good power is balancing it? You got to keep in mind the null hypothesis is not true. So increasing alpha means you're giving more rejection area in this picture. Shifting this line out, it'll give you more power because it'll make it more likely for you to decide that you're going to reject, and that's the right decision.
My brother sacrificed many things, Mr. Potter, on his journey to find power.
So alpha going up increases your power. So why don't we just always automatically increase our alpha? Because we don't know in real life whether the null or the alternative was true. So yeah, you're increasing power. You're increasing type 1 error rate if the null is true, right? So that's where people stick with 0.05.